Next topic is going to be on kind of looking at the data a little bit, kind of introduction on what to expect, and my 2 cents on data versus information is that there is no definition of what data is, no definition of what information is. So I don't know where one begins and the other ends. And knowledge would be the next one, but what is information? What is knowledge? So that's kind of, I don't know what is data, what is information, but sometimes people call data, this field, data visualization. Sometimes they call it information visualization. And for the most part, you start with some raw data or some data that you get that is available to you. I'm not sure if you may not get the entire raw data nowadays, because there are all these data sources available, open data sources. So you may not, it's not like I'm getting raw data, but somebody else put it out there. Maybe they make some changes, so it's not necessarily exactly raw. Like Census Bureau data. It's not. It's a data you can download. It's raw in the sense that it's raw to you, but the Census Bureau already processed that information and put it there. And I kind of took this one from a book. They had 3 other authors. I can't remember their last names. CMS. CMS visualization. It was a collection of articles more than anything, with a little bit of an intro. So this was in the intro section. And I've seen this in many forms, slight variation, but it's kind of true of the data. So we start with some data that we have. And based on that, we're going to create some sort of data tables. A lot of these visualizations, some visualization tools, especially the commercial ones, because they have different kinds of clients, they tend to put in more kind of readers that can interpret data in other formats. But at the very basic level, the data needs to be in form of a table, rows and columns, kind of like a database table. If you're not familiar, we'll touch it in the next a couple of slides we get there. So we put data in this more or less regular format that can be read by visualization tools. And by the way, it's the same format that most statistical analysis tools will use. SAS, SPSS, R. They all kind of want the data in the same format, in a table format. So we kind of have to start with some data, put it in a table format, and then we decide on visual structure. So the first step there is more of a data processing step, but you can get away without doing that. And sometimes it's an iterative process, like you pull, randomly 10 records and you look at them. You create the data table, or you go and pull them some more and you look at others. So after these data tables, they kind of get encoded, which kind of the name there is visual encoded, and it's chapter 3 in the book. In the textbook, that's more on the visual encoding. And actually, yeah, and then we come up with some sort of views. And those views can be manipulated. The simplest form of manipulation, you scroll. Left, right, up, or down. Let's think of a map. That's kind of a very basic form of manipulation. So I change the view a little bit. I don't change how it's encoded. I just change, a little bit what I'm looking at. So that's kind of the chapter 4 in the book, talking more about views. And then person looks at it and they can solve parts of their task and they need to do more. Many times I can go back and modify any of these things. And it may be a whole iterative process that you go through. You need more data. You need to create some sort of other columns from what you already have. Like if in the first homework, there's a lot of yes, no's. Maybe you can create a column that it says I have 3 yeses and 4 no's. So you see the tree rather than, or if you have, let's say if you have 20 yes, no's, then you create a column that's just one number, 0.4%, like tarantula in a way, pass, fail. They just have a color for a number, and it tells you where you are right there. So all of that ends up being many times an iterative process. So the original design of visualization is important, the interaction is important. All of them can help a person solve problems. And variation of this diagram will show up like later, like in other slides, from different authors actually. In terms of what types of data are we dealing with, and there's many answers to that, but here is kind of breaking down into three types. The first one is either sometimes called nominal or categorical, so categories or names, like cow, chicken, horse, dog. They're just names. There is not even an order between them. And there's one way to represent those and to deal with them, almost like text. But many times you saw the tools go through these, and sometimes they try to come up with some numbers out of there. The next type of data is ordinal, so things that can be ordered. Best example I have on this may be Monday, Tuesday, Wednesday, Thursday, Friday. There's an order there. And there's nothing in between. It's not like I have a Monday and a half and then Tuesday. So that's ordinal data. And then we have quantitative, which is basically your real numbers from math. So there is something in between. So I have a 1, between 1 and 2, I have 1.5 or 1.3. And I have intervals. And the other thing with quantitative data is that being a quantity, I can start to assess, and it shows up later in other lectures, start to assess kind of how many times. Like, for example, if I have 2, 4, 6, and 8, I see that 6 is about 3 times as big as 2, and 8 is about 8 times as big. Or the difference between 2 and 4 is about, about a quarter, well, 1/3 of the difference between 2 and 8. So it kind of, when I'm starting to have numbers, I'm starting to see these things. There are things in between, and then there's this idea of how many times. I start to see kind of magnitude of things. I have this here, so this is type of data. Now, if I have to encode it, obviously an axis like an x-axis is really good for numbers. Because I can put a 1 here, a 2 here, and it's kind of understood that there's something between 1 and 2. This is not as good for, I cannot do Monday and Tuesday here, because the axis kind of implies a little bit that there is something in between. Yet it still shows the relationship that Monday comes before Tuesday, or that Tuesday is between Monday and Wednesday. So I can still see that. And then the worst one to be represented, this would be something like, cow, dog, and cat. Because that not only implies there's a dog and a half, but also implies that the dog comes before the cat. So, like I said, it's not necessarily bad, but you're kind of getting away from it. You're starting to put more and more biases into that visualization. So each of these has kind of a way to some ways to represent them, and some ways that tend to be a little bit confusing to represent, especially for people who look at that stuff and say, "Hey, why did you put Ford before Chrysler or Chevy?" That's not the right order. So that's a thing with order there. The question I have here, it's not necessarily so if I these are if these were my choices, I can do a circle, a square. I cannot change color, a triangle and a star. I cannot change size, color, or anything else. They look just like that. What kind of data would be best represented by that? Okay, categorical. That's the right answer because this cannot. The circle can be cow and the square can be chicken. So I can see how many cows, how many chickens I have. I have no 3 circles and 4 squares. That's kind of the sense of what I'm getting here. It's going to be really hard to represent numbers if I say that the circle is 1 and the square is 3. It's just not going to be easy. So as you see with the axis, it kind of allows it, although this one is almost impossible to represent value numbers on. If I change the shape, that's the only thing I can vary. Some things we talk about when we look at the data, it needs to look like a table like this. Again, a table like a database. For the most part, we want to consider the columns fixed. And in a way, this can be thought of as variable, the how many entries we have. The number of columns, ways I refer to it and other people refer to them, and there may be more than that. So I can say the data has 4 columns, or it has 4 dimensions: name, income, tax, population. Attributes, also, that's another name for it. And even variable, if you're more statistically oriented when it comes more statistical talk. So they're kind of all referred to the same thing, is the complexity of this data. And then the size of the data is how many rows I have. In this case, 3 rows. That's kind of the view there. Can you flip it? Maybe. It logically doesn't make that much sense, but on some data that's really abstract, columns and the rows. On this one, it's not that straightforward. So that was a good data format. Like I said, most visualization, most statistical tools prefer it that way. Smarter ones will convert some of these into that, but you never know what you get at the other end. So what is wrong about, let me kind of go to the top example. I don't know, maybe let's say this is population. I didn't draw that. Maybe this is population here. And I have USA there's more things. Population, I don't know. Average family size, I'm making it up. I put some numbers in there. Average temperature. So, and the name of the country, obviously, and the name of the continent. So a table like that, it's good for people, but it's not easy to do by the, why? Because I don't have the same number of columns. On this row, I only have 1. On this one, I have 4. On this one, I have 4. Then I go to 1, and then I go to 4 again. So how do I fix this data set? In order to kind of figure out what's the complexity, how many dimensions, and what's the size of data, I need to do that. So what I would need to do is kind of repeat this heading, create another column, and repeat the heading on that one. So Canada is in North America. So call this continent and put in North America. This goes away. Oh, man. I'm going all over the place. And then Brazil stays, but it's going to be South America. or the continent. So really, you can see that now my data set has size 3 because I only have information about USA, Canada, and Brazil. And the number of dimensions there, the number of attributes is going to be 5. So I have 1 here, 2 here, 3, 4, and 5. And that's kind of how the data needs to be fed into many of the, I mean, I would say it's pretty universal way of looking at of data. On this other one, I had like temperatures, Little Rock, at 12 o'clock it was 84 degrees. In Benton, 12 o'clock was 82. At 1 o'clock it was 86. 2 o'clock it was 85. And then here I have 2 o'clock and 89. So what's wrong with this data? It's kind of it's first it has variable number of columns, but even if they were not variable, it's the same thing gets repeated. The same 2 gets repeated on this side conceptually. So that's going to make it harder to analyze. How would I fix this data? Yeah, I will have, there's really 3 dimensions to it. So it's the city name, time, and temperature. So it's going to be Little Rock at 12:84. And then at 1, you have to repeat Little Rock. At 1 is going to be 86. And then Little Rock at 2 is going to be 89. And same with Benton, you're going to have 2 entries here, Benton and Benton. I'm not going to spend time to do that. So basically, my data set really has size 6, 1, 2, 3, 5, sorry. Size 5 and 3 dimensions associated to it. So that's kind of how we have to make sure that a column is actually a column, is not repeating something else. So I don't have Q1, Q2, Q3. That should be just quarter. And I have the number of the quarter and the value, how many sales were on that. So that's the best way. It allows you the most flexibility when you deal with these tools to kind of go and fetch that data and modify it, put it into format. I have this visualization that doesn't work. I will get to it at the end. I think I have one more slide. For some reason, it does. It will show up properly in PowerPoint, but not in Collaborate. So not sure if I emphasize this, but visualization is a common activity. If you don't believe me, if you're in any car that's 5-year or 5-year new, go and look at it. The new ones, it's just a visualization. Most of it, they just show you information in a visual form. And some of them only have a touch screen. It's a computer. It's just a tablet and nothing else. So your phones are a visualization. They show you various pieces of data most of the time. Now, you can look at pictures too. I would say that's not necessarily data visualization, but the fact that it organizes the pictures, it becomes, it tells you when it was taken in years. It kind of lets you go through various apps, and apps let you access different kinds of information. So you have visualization everywhere. Another example, it hasn't happened yet, but it will. The Super Bowl. Well, there's visualization. I mean, I have the video, and that's not what I'm talking about, but if you look, it tells you the score. It tells you how many timeouts are left. It tells you who has the ball, how many yards they need to go. They keep experimenting with all this stuff they overlay on the field, like a red line, a green line, a gray area, things like those. So you have it for almost everything nowadays will have some sort of way of presenting you additional information. It's just what display technology graphics allows us to do. One visualization is not good for everything. It's good for some things, not for others. So you kind of have to pick and be able to come up with, and there is no perfect one also. There may be 2 or 3 that are kind of good enough and about the same for a certain task. Coming up with it is not trivial. I know there are tools out there, but they tend to, there's some that are very easy to use, but they tend to give you kind of cookie cutter views all the time. There are the ones that are trying to automate it and not give you the same thing all the time, but they will end up, the computer will end up, at least me, making me crazy because I want to do something, I know what I'm doing, but it's never offering me that. And that's kind of, you have to play with that a little bit. There are some that you can go through an API, so you have a programming power, you can customize a lot of things, and you can process your data on the fly. But you need to do coding with them, which, again, maybe not everyone in this class. No, I'm aware of that, so I'm trying to kind of stay away from necessarily heavy coding. But if you're comfortable with it, there's quite a lot of tools out there. All this AI stuff and machine learning, it's, as a side effect, they kind of made visualization a lot easier in a lot of languages. You just download the package and it almost works out of the box for very simple things. And the thing I wanted to show you before is it's more or less this data set with the name of the country, income tax, and population. And actually, the area of the country is also included in there. So that's also a semi-famous visualization presented, again, to the British Parliament. The point they were trying to make, I'll show you in a bit. Let me talk and click. The point they were trying to make is that if you look at the Russian Empire, for example, I think the size of the circle is the area it occupies, kind of on the map. And then you can see population and tax, population and tax. The only ones that need to go up here looks like it's the British and Ireland. They made it look like everybody else is kind of sliding down. They have an easy way. They're not taxed that badly. And you can kind of see that that's the point that he was trying to make. And I guess that's one way to do it. Interesting thing is why they use 2 y-axes, which is okay in most cases, where you don't look at the same value. In other words, here population and tax are kind of independent of each other. If I were to look at the stock market, the price and the volume of the trade, those are kind of independent most of the time. So those make sense. So it's almost like if you're using another unit of measure for the 2 axes, that typically tends to work. If it's the same unit, then I think you may run into trouble that way. But all of it depends on the problem, on the data. And there may be cases where you're good with 2 of them with the same unit. If, for example, one of them changes quite a lot and the other changes a little bit. So if one of them, it's the same unit, like speed, but no. A ballistic missile goes 40,000 miles per hour. I'm not sure if it goes that fast. Or a satellite goes 40,000 miles per hour. And then you want to compare something with, how fast an ant moves in the satellite. If you put it on the same axis, there's not going to be any comparison. So, like I said, you have to look at the problem, you have to look at the data and decide. And that concludes